Hello everyone, welcome to another physical sciences lesson. I'm really excited to be continuing our investigation of electrochemistry today. And for today's lesson, we're going to be introducing you to a different type of electrochemical cell. Not the galvanic cell, today's the chance for the electrolytic cell. So let's go and see what it's all about. So the first thing I want to ask you is to think about this question. When is electricity used in chemical reactions? Now, this might be something that you've heard of. You might have even seen it or studied it in a textbook in earlier grades. Think about, where is electricity used to make a chemical reaction happen? We're not talking about the galvanic cell where we used chemicals to make electricity. Now, where can we put in electricity and get a result of a chemical reaction? Think about it. And as you do, we'll go to our overview. So in electrochemistry, we have electrochemical cells, and there are two types. The one that we've dealt with, the galvanic cell, and we can call it an electrochemical cell because it's got chemicals in it and it's giving us electricity. The second type of electrochemical cell is the electrolytic cell. And this electrolytic cell works in a slightly different way to the galvanic cell. But there are some things that are common, and we need to go and discover exactly what's happening. So if you look at the concept map, you'll see that the electrolytic cell also has an anode, just like the galvanic cell. It has a cathode, just like the galvanic cell. It also depends on redox reactions. It is also involved in energy transfer, and we're going to have to look at this. The most interesting thing is that there are lots of applications for the electrolytic cell. The galvanic cell, yes, it provides us with ideas about how to get electricity. But that's largely been taken over in the world today, perhaps with one exception, but by generators. There is some movement in terms of research about battery technology and converting solar energy to battery power that can be stored. And there are even things called fuel cells that can do both of these types of processes in the galvanic way and the electrolytic way. So it's a very exciting field of research. So let's get the fundamentals in place so we can understand it in a little bit more detail. So our focus today, electrolytic cell, but here just to remind you, the galvanic cell. Remember, there was an anode, and at the anode there was oxidation. That was the zinc electrode, and we had electrons that went from the anode, which was negative, through the voltmeter to the copper electrode, which is the positive electrode, where it is known as the cathode because it's gaining electrons, and that's a reduction reaction. So remember the little terms that we used, like oil rig, where we said oxidation is a loss, and rad, oxidizing agent takes electrons. And when we said the red cat, and we said that was at the reduction takes place at the cathode, and anox, because we got oxidation taking place at the anode. All of these terms still apply, and we're going to use them for the electrolytic cell. So there's no need to change things around. We've learned our definitions once. Here, let's focus on energy transfer. This is a popular question in the exam or a test. So you need to know it very well. Remember what we know so far? We can take electrical potential energy, we can use a galvanic cell, and it will produce for us electrical energy. In your electrolytic cell, it takes the input of electrical energy and it produces for us chemical potential energy. So the electrolytic cell is like the electric motor. It's taking input, electricity, and it's giving output as a chemical reaction. This process is called electrolysis. But let's pick up some of the terms we need to know. So just like we had a solution in a half cell where we would make sure that we've got ions in solution, ions that can move in a solution, that's your electrolyte. We have an electrolyte in the electrolytic cell, a solution of dissolved salts, or some acid might even be there, some hydrogen ions, but the ions are necessary for conduction. If we have only covalent molecules in the cell, we know the conductivity will be very low. So it has to be with ions in the solution. That's the first point that we need to know. The electrode is simply the surface that will deliver the electricity. That's a conducting surface where the electricity is going to be formed, and that's where the reactions are going to take place. In the electrolytic cell, we usually use a variety of electrodes, but the most common one that we use for simple stuff is the graphite electrode. That just is a carbon electrode, but you'll see that there are, in certain applications, other electrodes used. But the standard one is the graphite electrode. So the electrolytic cell is where electrolysis takes place. And electrolysis is really an important historical chemical reaction because it was used to take compounds. We could take a compound and we could break it down into elements. And so it was really exciting, and it was one of the reasons why we know the chemical formula of certain substances. So let's just go and look at the process in a little bit more detail. What do you see in this electrolysis of copper 2 chloride? Well, if I look at it, the first thing that stands out is on this graphite electrode, you'll see it's black, we've got bubbles. And these surely must be bubbles of chlorine. The second thing is, you notice there's a source. That source is a battery that's allowing a movement of charge, and at this electrode we're getting some copper being deposited. So the graphite electrode, which was black, has now changed to that orangey copper sign. So we can see that when we started with copper 2 chloride, we've now got copper and chlorine gas. So we can write this reaction as a chemical equation. Look, copper 2 chloride produces copper plus chlorine. In the symbolic form, we say CuCl2 solid gives us copper solid, the orange deposit, plus Cl2 in the gas form. So you can see that there's something happening here that is really interesting. We were able to split apart the initial salt, copper 2 chloride, and produce the elements that make up that compound. Let's go and look and see exactly what's happening there. So this is the start of the reaction. And we've got something in the solution that is copper ions. And we've got some chloride ions. And notice that there are graphite electrodes. This is graphite, which is just carbon, and they're both exactly the same. Notice there's no movement of charge here because the circuit is open. We've opened the circuit. This is the start of the reaction. What happened is we took the copper chloride, which is a greenish colored salt, and we dissolved it in water to produce those ions. Those ions are swimming around. The copper ions, remember we call those cations, and the negative ions we call anions. Let's represent that in the equation. So at the start, we're going around and we're saying what has happened is we've taken the copper chloride, and it was a solid, and it's formed these ions. Now, in forming these ions, when we close the switch and we bubble the thing through, notice what happens. We get the copper deposit over here, and we get chlorine gas over here. So overall, those are the products of the reaction. Notice that we've been talking about the electrolysis of copper chloride. But it's not the only one that we can look at. In fact, a very interesting one is the electrolysis of water. Now, normally water doesn't conduct too well, so we add a little bit of acid, some hydrogen ions into the solution, and then look what happens. Water, produces the elements, hydrogen and oxygen. And it looks a little different to the electrolytic cell where we were doing the decomposition of copper to chloride. But can you see here, we've got two electrodes, we've got two areas where gas is collecting. Which one has collected the most gas? Where the bubble's the biggest? Well, this is the hydrogen being produced, and we could test that, and this would be the oxygen. And what you should notice, if you do this reaction, is this is less volume. There's less volume here, and there's more here. And in fact, there's twice as much. And when we write it in the chemical equation, you'll see the ratio of hydrogen to oxygen is 2 to 1. And so that was historically how they discovered that water has a chemical formula of H2O. I'm sure you found that interesting, but you know what? I think it's time for a short break. We'll be back to explore the reactions taking place in an electrolytic cell. We'll see you now.